So, matrices and matrix algebra, how to work with matrices. And for some of you who have taken the ACT test, there's been a matrix or two appearing on ACT tests lately. Come on. There we go. So we're going to look at matrices, matrix addition, subtraction, matrix of multiplication, identity inverse matrices, and determinants of square matrices. A matrix is rows and columns of numbers. Okay, you think of it like Excel. It's like a spreadsheet of numbers. Okay, so first row, first column is 1, 1. First row, second column is 1, 2. Fourth row, third column would be A 4, 3, and so on. Okay, so you can see which ones are what. Okay, matrix vocabulary. Each element or entry of a matrix uses the subscripts so you know where you're at. Okay, rows are first, columns are second. So an M times N matrix is this many rows, this many columns. So 4 by 3 matrix is 4 rows, 3 columns. Okay, you always go rows, then columns. All right, so what's the order of the following matrix? This is a 2 by 3 matrix. Okay, 2 rows, 3 columns. So if we add matrices, we add the corresponding positions in them. So if you add A plus B, you're adding this one to this one. Or if you're subtracting, subtract them. And that's not a good example. We'll actually get to a good example here. So when you're adding and subtracting, same corresponding positions. You add the 1 to the 2, the 2 to the 3, the 3 to the 4, the 4 to the 5, the 5 to the 6, and the 6 to the 7. So this winds up equaling 3, 5, 7, 9, 11, 13. Are we good there? Okay. Basic math. Okay. Scalar multiplication is we multiply every number within the matrix by the number outside the matrix. So this is 3, 6, 9, 12, 15, 18. Boom, boom. Easy peasy, lemon squeezy. The zero matrix is 0. Matrix multiplication. We take row 1 times column 1 to get element 1. Then row 1 times column 2 to get element 2. And then row 2 times column 1 to get 3. And row 2 times column 2 to get 4. So this will have 4 things in it. Since this is a 2 row by 3 column matrix and a 3 row by 2 column matrix, when you multiply these together, you'll get a 2 row by 2 column matrix. The outsides is what your final matrix will be. The insides must match or you cannot multiply them. The inside numbers must match or there's no multiplying them. So when we multiply these together, and maybe on the next slide they'll have more room. Okay? Nah, I'll go back. So this equals, so I take the whole first row times the whole first column. So I take 1 times 1 plus 2 times 2 plus 3 times 0. This times this, this times this, this times this. And that's my first element. My second element is going to be top row times second column. 1 times 0 plus 2 times 1 plus 3 times negative 1. Then this element down here will be 0 times 1 plus 1 times 2 plus negative 1 times 0. And the last element will be 0 times 0 plus 1 times 1 plus -1 times -1. Then you just do the math of each of those. 1 plus 4 plus 0 is 5. 0 plus 2 plus -3 is -1. 0 plus 2 plus 0 is 2. 0 plus 1 plus 1 is 2. So that's matrix multiplication. So let's see if my 5, -1, 2, 2 answer is correct. Hey, there's the answer. I was actually right for once. The identity matrix is ones in an angled down column like this with zeros everywhere else. Okay, that's the identity matrix. Okay, and so we use the identity matrix when we're working with multiplication. So that way we can get answers that we need when we're solving equations simultaneously. And we'll get there. So to find the inverse of a matrix, you take the matrix and take 1 over A times D, these two times each other, minus B times C, these two times each other. And then flip these around, leave these two alone, but put negatives in front of them. And yes, that's a little bit complicated. Okay, but we have to know how to do the inverse so we can multiply them properly. Okay, AD minus BC, D, negative B, negative C, A. And you can only take inverses of square matrices. And so we're only going to work with inverses of 2 by 2 matrices. Now, we'll get help from the graphing calculator to do other ones. All right, so the inverse of this matrix equals 1 over. We take 5 times 3 minus 8 times 1. We flip around the 5 and the 3, and then we go opposites of the other two. Okay, so this is 15 minus 8. What's 15 minus 8? So we have 1/7 of 3, -1, -8, 5, which is 3/7, -1/7, -8/7, 5/7. And that's the inverse of this matrix. So this would be a inverse. So it just follows basically a formula. So if you can do the formula, plug the numbers in, it's not that hard. Okay. So if we multiply inverses times each other, we should get the identity matrix. Matrices, if we add them, are commutative, but not if we multiply them. Associative property, it works for addition and multiplication. Maybe. An identity property, I'm not worried about that. You're not going to get tested on that. All right. Let's look at okay. So what would be A12 of this? 1, 2 means first row, second column. What number is that? 9. What would row 3? Does not exist. Do we have 3 rows there? No. Okay. So, can we add these matrices together? Yeah, they're both the same, so we can add them together. So, 3 plus 5 is 8, 9 plus 3 is 12, 7 plus 6 is 13, 7 plus 7 is 14. We added them. Can we subtract them? Well, if we can add them, we better be able to subtract them. 3 minus 5 is negative 2. 9 minus 3 is 6. 7 minus 6 is 1. 7 minus 7 is 0. We can multiply negative 3 times a. Just take negative 3 times each of the numbers. Negative 9, negative 27, negative 21, negative 21. And then I could take 4a times 2b. Yep. Yep. She was with me. She was with me the whole time. Yeah. Yeah. So, yep. Yep. Sounds good. Bye. Izzy, did you check in with Mrs. Richards? Oh, you don't tell somebody to tell. You check in with them yourself. Okay. 4a2b. So you take 4 times this, and you get 12, 36, 28, 28, plus 2 times this, which is 10, 6, 12, 14. Then you just add them together to get 22, 42, is that 28? Yep. 40 and 42. Easy peasy, lemon squeezy, right? Four times each of these to get this. 2 times each of these to get that, and add them together. Okay, that's fine. Okay. I'm not going to do this one because we don't have to. All right, multiplication. This is where everybody starts freaking out. Okay. A times B. Rows times columns. What's my final matrix going to be if I take a 2 by 2 by 2 by 2? 2 by 2, because you take the outsides ones. So, you take negative 4 times negative 7 plus negative 9 times negative 4. And you go, where'd you get that, Bierschbach? Well, I took this row times this column. This times this, this times this. Now for this item, row, column. Okay? So, negative 4 times negative 5 plus negative 9 times 6. Okay? So on bottom row, first column. Okay? It's just where they cross is the numbers that where they go. So, negative 8 times negative 7 plus negative 5 times negative 4. And the last one is negative 8 times negative 5 plus negative 5 times 6. So, doing the math, 28 plus 36 is 64. 20 minus 36 is negative 16. 56 plus 20 is 76. 40 minus 30 is negative 10. Good? Okay. Now, is B times A going to be the same thing as A times B? No, not at all. So you take, and for me to do this, I got to rewrite them in order because I look at them and everything goes wacky if I don't rewrite them. So, first row, I take -7 times -4 plus -5 times -8. Then I take first row, second column, -7 times -9 plus -5 times -5. Then I take -4 times -4 plus 6 times -8. And finally, -4 times -9 plus 6 times -5. Everybody see where I get the numbers from each time? Okay. So this is 28 plus 40, which is 68. 63 plus 25, which is 88. 16 minus 48, which is -32. And 36 minus 30, which is 6. They obviously do not match even close. Okay, so A times B is totally different than B times A. All right? So we have A, B, B, A, B, B, A, B, B, A. Yeah. So 9 questions. It's going to take you a good half hour to work on this. So get to work, please. I will put it out there for you. Oh, I already